So we have the integral of the square root of x plus 7 to the 8th power divided by square root of x, and then we've got the dx on the outside. So the u is going to represent the inside of the function. What looks like it's inside? Root x plus 7. To find the du, I have to take the derivative of this, so I'm going to go ahead and rewrite it so it's easier to take the derivative of. So what should I rewrite it as? X to the 1/2 plus 7. Okay, and then when I take the derivative, all right, and then I've got dx. Derivative of x is dx. Okay, so let's go ahead and rewrite this. So if I clean that up, what do I have? 1 over 2 root x, okay? Now I can see, I'm going to show colors. I can see the root x, I can see the dx, I do not see the 2. Does that make sense? What? I can see the root x on the bottom, I can see the dx, I cannot see the 2. So what do I need to do with that 2? I need to pull it out. All right, so when I multiply it out, so right now I've got du equals 1 over 2 root x dx, and I'm going to multiply each side by 2. So I've got 2 du equals 1 over root x dx. Okay, so if I'm replacing everything in the problem, then this is u. Does that make sense? And then this stuff is going to be replaced with 2 du. See how this is this stuff? So it's going to get replaced with 2 du. Does that make sense? Okay, so cross it out, 2 du. Ah, does that make sense? Is it clearing up from last night? Okay. Well, so I'll talk it through the same way next time and then keep explaining it, and I think you'll pick it up as we do it a couple times, okay? All right, so at this point, we are integrating 2 times the integral of u to the 8th du. And what do I do with that?
Plug in u into here. Just integrate.
Yeah, use the rule, right? U to the 8th plus 1 divided by 9. Still got the 2 on the front. What do I do on the end? Oop, before that. What do I do on the end? Plus c. Okay. Okay, so what do I have now?
2u to 9 to the 9 over 9 plus 2c.
Okay, now I typically write it like this because I would rather have a coefficient than have a term that's divided by a number. That's just me. But it is possible for you to see it on a multiple choice answer as 2u to the 9th over 9. That is definitely possible. Okay, when I do 2 times a constant, what happens? Actually, that wouldn't even... No, it would. It'd be multiplied to everything. So when I do 2 times a constant, it's still a constant, right? It's just a constant that's twice as big. I'm still going to just write plus c. Okay, so now what do I do with the u?
You plug back in.
I plug the part that I took out. Okay, so u is representing the square root of x plus 7, so I can stick that back in there to the 9th plus c. And this is where we make sure to have the plus c so we don't kill any hedgehogs.
Would it be okay if you put plus 2c on?
Don't put plus 2c because it's going to mess you up later. All right, example 7. we're going to do the integral sine of sine x cos x dx. All right, what's the inside?
Sine x.
Sine x. So u is going to be sine x. The derivative of u is cos x dx, okay? And so I'm going to say that this right here is the u, and then this right here is du. Do we see that? This is u. This is the derivative of u. All right, so what are we integrating?
Sine u.
Mm-hmm. Is the original problem? I mean, we took out the inside. Sine u du. It was sine of sine x. The sine x was inside.
I mean, yes.
Plug everything back.
We have the whole point.
Yeah, I haven't done the integral yet. I haven't done the integral yet.
Now in a usable form.
Yeah.
Now
Well, now it just looks nicer because it's not in marker. Yeah, you were right. It was the same thing. I just rewrote it. All right, and then the integral of sine
is just negative cosine.
is negative cosine. So we've got negative cos u plus c. All right, and then what do I do with the u?
Turn it back into sine.
Take it out, put a sign back in there.
Is this just a nicer way to do these, or is it the only way you can do them?
It's not that it's a nicer. We couldn't do them if we weren't doing this.
This is the equivalent of the chain rule.
Backwards. Yeah.
For the du disappears because it's just like the dx. Right?
Well, it doesn't disappear. It's because this is talking about rectangles, and now we're going backwards and we're doing our units, right? So we're saying length times width equals something as a whole cohesive group.
It's just like dx.
Yeah.
It disappears.
Right.
No
Right.
You still need it to do the.
You still need it for the problem, and the reason you need it is because you have to be able to find it in the problem. So the real important part about du is in a problem like this, where you're looking for it and not all of it is there.
And so you have to end up slapping
Like an extra number.
stuff on
Yeah.
the outside.
Yeah. But it's that idea of integrals have to have a length and a width, and the du or the dx is the width. And so to be proper about it, you do have to have a dx or a du. But in the case of U-Substitution, that du helps you make sure that you're accounting for every single little piece, just to make sure you don't miss something. Okay, let's do the next example. Example 8. You guys are very chill about this today. Which,
Well, we're all very tired.
that's fair.
Yeah.
That's for
I can make a problem right here.
All right. So, what is our inside? Cos x plus 2. So this is the u. Do you like my u? All right. And then the du okay. So what do we see?
We see a sine x and a dx.
Okay, so this and this together are du.
So you don't, when you find the du, it's not what the inside is of, it's the extra stuff.
It's the extra stuff. So once you say that this is u, you can't use it anymore.
And then the cos is attached to that. So
The cos is attached to that. Okay, so this was our du exactly, which means we can just write down what we have left over, right? Wait, what's the derivative of cos?
Negative.
Negative sign. We almost have it. See how we don't quite have it? What's wrong with it?
So we have to multiply by -1.
Yeah, so we're going to multiply the negative over to this side. Make that positive. So derivative of cos is negative sign. So this is actually a negative du. Okay. So I'm going to write it this way before I clean it up, okay? I have cos u times negative du. And that's because of the negative from the sign. I moved the negative to the other side.
Why was the sign D?
But it's the derivative of cos.
Derivative of cos is negative sign. Negative sign dx. And then we wanted it to be positive sign because the problem only has a positive sign. And so I moved the negative over to the other side with the du. So when I look at this, the sin x and the dx, I say, okay, that sin x and that dx are actually negative du. Okay, so I've got cos u times negative du. What should I do with that negative? I'm going to move it to the front. So negative cos u du. Okay, now what do I do? Integrate. So the integral of cos is sine. So I've got a negative in the front, and then I've got sine u plus c. And then what do I do?
Substitution.
Yeah, I substitute. You can think about this being in parentheses and distributing the negative, but it doesn't change, does it? Because if you multiply a negative times a constant, you still have a constant. Does that make sense? So it really doesn't matter. So negative sine u. It will confuse you later because basically the way you think of a c is no matter what you do to a c, if it's a number, you can multiply it by a number, you can divide it by a number, you can add a number to it, subtract. That c kind of absorbs all of it, and it just stays c. So a constant plus a number is still a constant. Yeah, just it absorbs it. So it doesn't matter. So if you want to skip this part of it, you don't even have to write it because it's always just going to be plus c.
Well, if you raise c to 0 with power, though, it turns into 1, right?
But you're not going to do that in a problem like this. Okay.
No, I know, but if you did.
But we're
This is one
not.
of the questions
Yeah,
you
this
said
is
not to
this
ask.
is what we're doing. Yeah. Okay. All right. So what do I replace the u with?
We previously measured out cosine x plus 2.
Cos x plus 2 plus c, and done. All right, with this one, okay, we're going to go ahead and go into it. This one is an interesting problem. Trying to decide if I should do it now or later. I might do it later. I'm going to let you guys practice a little bit before we do this one. Okay, we are going to add one more thing, though. We're going to do integrals of symmetric functions. Integrals of symmetric functions.
How much space will this take?
I did it in half a page and I write big. All right, if f is continuous, on negative a, the closed interval, negative a to a, then we have two different potential conclusions we could make. If f is an even function,
What is that? What is even function?
you tell me it was in your summer assignment. Anyone remember what an even function is?
A function that's
It's symmetric across the y-axis. X squared is a good example. So x squared is an even function. It is symmetric across the y-axis. X to the fourth is another even function. X squared plus x to the fourth is an even function. Yeah.
So is it, if its leading exponent is raised to an even?
Well, I gave you polynomial functions, but it could be, there's trig functions, there's all sorts of different functions that are. So cos is an even function.
So essentially.
Sine is not.
Oh, it's not?
Sine is not, cos
Yeah,
is.
so
If it's a polynomial function, is it that the leading exponent is
Not leading, it would have to be all of them.
Okay.
Because x squared plus x is not even anymore. Okay. So if you need more details, you got to look back at your summer assignment because I went all into it in that. All right. Nope. All right. If f is an even function, then what happens is you can plug a negative x into the problem, and it spits out the exact same y coordinate as if you plugged in a positive x, which is why it works like in a parabola. You plug in -2, you get 4. You plug in +2, you get 4.
Makes sense.
All right, so
we
like
use
squared,
this
so
to
it's-
test if something is.
that's how you test to see if something's even. So if we have the integral from -a to a of f of x, if f of x is an even function, then you say it's double of 0 to a. It's just a nice little shortcut. So for example, we're going to go ahead and draw a parabola. If you wanted the area under the curve from -2 to 2, you don't actually have to find the area from -2 to 2. You could just find the area from 0 to 2 and then double the area.
Oh, because
makes sense.
It comes in handy later on in BC when you have more, like with something this simple, it's like whatever, I'll just do it -2 to 2. That's not a lot of work. But later on, we start looking at functions where knowing the symmetry actually really saves you some time. So that's what we're kind of gearing up for. All right, the other option is if f is an odd function. Anyone remember what makes an odd function?
it's not.
The x-axis?
It wouldn't be symmetric over the x because that's not a
It's
function.
not symmetric over the y.
It's on the y-axis.
It's not symmetric over that. It's symmetric about the origin, which means you can spin it. So x to the third, right? Think about it. X to the third goes up like this and goes down like that. And if you spin it, sine is another one that's odd. X to the fifth plus x to the third plus x is odd. X to the third plus x squared is not odd. It's not odd, it's not even, it's neither of those. So you don't have to be one or the other. It's possible to not have any symmetry at all in a graph, right? Not every graph has symmetry. X squared plus x would be an either. X to the third plus x squared would be an either. A lot of, I would say more often than not, if you have like all the graphs that are possible in the world, most of them would be an either, but we have specific ones that could be even or odd. Okay, so this is saying specifically a graph that has symmetry, which we know is not a lot of graphs. A lot of graphs do not have symmetry, right? That we've like looked at in our lives. Okay, so in this case, we would say that if you plug in a negative, it gives you a negative y coordinate. So if you think about the cubic graph, if you plug in -2, you get -8. If you plug in +2, you get +8. So they're giving you the same value for the y coordinate, but just opposite signs. That's what an odd function would do. Okay? All right. So here, and I didn't even write that, but we could write that. We could say this is symmetric to the y, and this one is symmetric to the origin.
So it has to give you back the same value.
Just different sign. All right, so this one is saying that if we take the integral from -a to a of f of x, and I'm going to draw a picture of this, and then I'm going to let you guys tell me what the answer should be. So here's a cubic. Let's say we want the area from -2 to 2. What would the area be? 0. The negative version perfectly cancels the positive version.
Oh, we've looked at that before.
Okay, so those are just handy. later on it will save us time. I have found maybe 1 or 2 questions here or there where you actually have to remember this to be able to do the question. A lot of times it's a time saver, but it's not necessary to do the problem. But every so often they will say something that is very specific to this. They'll say like, so this thing is an even function, find in the multiple choice answers the equivalent integral. And then you have to know that if I did 2 times 0 to a, it would be the same thing. So every so often they'll ask something that's specific to this, but more often than not, it's just something that saves you time. Does that make sense? Okay, so we're going to do some Larson problems. So go ahead and get out a blank sheet of paper. Okay, so what is the inside?
3 minus 4 squared.
Du would be, okay, and do we see that? Yes, and they even wrote it next to each other to make it nice and obvious.
Thank you.
It annoys me when textbooks do that. All right, so what do we have now?
The integral
U cube root. I'm going to write u to the 1/3. Are you guys okay with that?
Okay.
Okay. So now what do I do? Add 1. Divide by that. Did everyone get their plus C?
Yep.
Anybody? Are you sure? Anybody kill a hedgehog? Little baby? Do I need to mark it? Do I need to mark it? All right. So got to bring the 4/3 up. What do we have?
It's not a hedgehog if you do it on purpose because you're evil.
Yeah, then you're just like a hedgehog hunter.
Is the baby dead?
He's already a
Killed
deer
on
hunter,
purpose
so.
because you're a horrible person.
I mean, is it dead if you shoot it with a gun when you're hunting? Yes, yes it is.
You're hunting for that dead baby.
Yeah.
Ooh, can I hunt for a Bambi?
Let's do it.
All right, then what do I write next?
3/4, 3 minus 4 squared to the 4/3.
Okay, what's another way I could write it?
With a radical and cube. Or radical and a hypercube.
But we're not going to say that anymore.
Yeah, we're not going to say that. We're in a college level class. We're going to be college level.
Can you distribute?
Tell me, can you?
Yes.
Because the exponent.
No, I'm saying, can you distribute the exponent?
No.
You could. It
If
would
you
just
wanna
be
kill a
really,
kitten.
really annoying.
No, I'm saying by foiling.
You wanna multiply that out 4 times?
Yes.
No.
You feel free. Go ahead. All right.
Go for it, Toby.
You
Save your dreams.
won't. You won't.
All right, we're going to do number 12.
It could be so much better because then you could distribute 3/4. Why would we do more work than we need to?
And I guarantee you that would not be a multiple choice answer.
For aesthetics' sake.
No, it wouldn't be aesthetic either. It would look terrible.
Oh, no. I'm
We'll just waste time.
In response to the why would we do more work to make things look good. That would not
Fine
look
as it is.
Yeah. All right, what's
It
the
looks fine.
inside?
5x squared plus 4.
All right. Students, once they learn U-Substitution and we start mixing everything up, they often ask me, how do you know if you need to do U-Substitution or not? And the answer is you look to see if there is an inside. It's the same answer as how do I know when I do the chain rule if it looks like there's an inside. Does that make sense? So if you had an x plus 3 inside, you got to write the x plus 3, right? The derivative will be kind of nice, but you still got to write it. Okay, so the only thing that's not going to need you to do U-Substitution is if there is an x all by itself inside the parentheses. Does that make sense? Like before. All right, so we've got u is 5x squared plus 4. Du is 10x dx. I see an x dx. I do not see a 10. Divide by 10. Okay, so x dx, so this and this are going to be replaced with a 1/10 du. You see that? So the x dx is getting replaced with a 1/10 du. And you can see I've replaced everything except for the exponent of 3. Okay, it is. All right. So now I've got 1/10 u to the third du. You can leave the 1/10 inside or you can move it to the front. It's up to you. All right. Now what do we do?
You take the derivative.
The
Or
antiderivative. So u to the third plus 1 divided by 4. Don't kill a hedgehog. So what do we have? 1/40th u to the fourth.
Would you put u to the fourth on the top so it's u to the fourth over 40?
I often don't do that because I found a lot of students forget that it's a coefficient if they do that. So I like to write it this way, but you will definitely see in multiple choice problems that they've done that. All right, 1/40th.
U.
Okay, are we feeling a little bit better about it? Should I redo the video to do this? Would that be better? Or do you think it was okay to do it the second day? This makes it worse? Okay.
Well, I'm just thinking of them both now. And it's
Yeah,
like,
why don't you?
I'm doing the marker to show you that everything gets taken care of.
I don't understand when you like say you're gonna replace the x and the dx, but you don't you like split them up.
I didn't split them, I was circling them like they're
No,
together.
but you say they're both being replaced by 1/10
Mhm.
but then you write them split up.
No. You write them split
Let
up
me-
for that.
Let me rewrite it
They're
real quick.
originally written in split up fashion because the problem comes in split up fashion.
So
but
this
you
is
can
u
write
to
it
the,
if you want.
this is u to the third, and then the x dx is 1/10 du.
So the x is like the 1/10.
See how I said du is 10x dx? But then when I looked in the problem, I was like, I don't have a 10x dx, I only have an x dx. So I divided by 10 and I moved it over here. And then I said the x dx is going to be a substitution with the du over 10, or 1/10 du. So I said this is u to the third, this is 1/10 du. You don't have to do it a marker if you don't want to, but what I'm doing is I'm showing you that everything gets taken care of, that nothing gets left out. Yeah. Because of this 3 right here. So the third exponent, the third x is like the outside, right? The inside is, if you think about the chain rule, remember how we did like the derivative of the outside? The to the third power is the outside. The u is the inside.
And you just fill in the u.
Mhm.
You get the 1/10 because you're doing
Mhm.
u divided by 10.
Mhm.
like if we're sine x, so it becomes sine u.
Mhm. Okay, are we ready to practice them?
Mhm.
Yes? Okay, so go ahead and get started on those, 5 through 25, and then the other ones it says on the board. When we get down to... Later in the period, I will show you... Oh, maybe it's over here. Later in the period, I will show you the last example, okay? I just want you guys to be fairly comfortable before I show you. Okay? All right. All right, example 9. In my head, I think of these as more complicated U-substitution problems.
Or is this problem? Or is it just one you're giving us?
It is not one of the ones out of the book.
Okay.
It is one that I'm just giving you. Okay. So what's the inside? Okay. So u is 2x minus 1. Du is 2. dx. There's no 2 hanging out by itself in the problem, so we're going to divide the 2 over. All right, so that means that this is the u. This is going to get replaced with 1/2 du, and we got an x in the front that we got nothing for.
Wait, so
Yeah.
can we do that and make put u and or x in terms of u?
So we're going to take this. We're going to solve for x. So we're going to rewrite a plain old x in terms of u. Yeah,
So
new
plus
x.
1 over 2.
So I started off the problem just like normal. I said I could see the inside. And the inside was 2x minus 1, and then I did the derivative of that like normal. And I didn't see a 2 hanging out over here, so I divided the 2 over and I got 1/2 du. So at this point, I've taken care of the stuff underneath the radical. I've taken care of the dx. All of that has been figured out. The problem is the x in the front. So then I said u equals 2x minus 1, and I did this work right here to solve and see what x was, but written in terms of u. So now the x in the front is actually u plus 1 over 2. Okay, so what I have is the integral. I've got 1/2. That's from the du. So this 1/2 I wrote in the front is from this right here.
Why do you write that?
Just because I like to move my numbers to the front. Okay. And then I have a u plus 1 over 2, and I have a square root of u, and I have a du. We okay with that so far? I'm going to take this 2, and I'm going to pull that to the front as well.
So multiply that 2, so it just gets 1.
No, because it's on the
Oh,
bottom.
divided,
It's
multiply
1/4. It's kind of like I had a 1/2 in the front, and I took this 1/2 and I pulled that to the front as well. So 1/4 u plus 1 times the square root of u du. Tell me why I'm rewriting it like this.
Because you're gonna have to do the integration.
Yeah, I can't do integration yet, but I'm going to distribute this. So what I'm doing is I'm avoiding another U-substitution problem.
So you could do a mini U-substitution.
Honestly, I've never seen that. I don't doubt that it would happen, but I've never really seen it. All right, u to the 1 times u to the 1/2.
Just u to 3/2.
U to the 3/2. 1 times u to the 1/2.
1 u.
Okay. At this point, can I use my little shortcuts now? Yeah. Okay. So I've got the 1/4 in the front. I've got u to the 3/2 plus 1 divided by 5/2. U to the 1/2 plus 1 divided by 3/2.
I am really, really, really tempted to just make that u to the power of 2.
So 5/2. Oh, you can't add those.
I know.
Very tempting. Yeah.
I almost said, why didn't we add them? And then I realized.
I almost was about to add them. And then I stopped myself.
It's
Yeah.
so it just looks like it's
God. Jesus.
Why would it not sound good?
Okay, we good so far?
More or less.
So I'm not doing anything in my head. I'm writing it all down. Because these are fractions and they go bad fast.
They're already bad.
Like trying to add.
Yes. 1/4 times 2/5.
1/20 or
2/20ths, which is 1/10.
Plus 1/6.
1/4 times 2/3.
1/6.
1/6. 2/12ths, which is 1/6.
plus C.
Okay.
Do we have to give them a common denominator?
No.
Would a multiple choice ever give us one with a common denominator?
I'd say they leave these alone pretty much.
It's 60 u to the 5 halves.
30 plus 10 u to the 3.
30.
Oh, I almost forgot we were u before again.
So did I.
Yeah, sometimes when you've done so much.
You just go, hey, this is the end of my journey, right?
Yeah.
Hey, you.
The journey is the destination.
End of my
Steven.
journey,
Just
right?
get caught.
The journey is the destination.
Wait a second.
Hold up.
So, this is the trick when you get to 61 through 65 odd. Shall we do some from your homework?
Yes.
Oh, wait.
Yeah, I already did all.
I thought it was 69 through 75 odd.
Oh, did I not assign these?
Yeah, you did.
You only
Okay.
assigned 69 through 70.
Well, good. We're going to do some together then. All right, 61. This is good to practice. It's not that it happens all the time, but it happens. Not all the time. I want to say I got through like the first year teaching calculus, and it wasn't until we were studying for the AP exam that I ran into a question that needed to do this. And I was like, what? That's U-Substitution, but it's not, but it is, but it's not.
It's very rarely.
Yeah. All right, so what do I do?
Get you.
Get U. U
plus
is
6.
x plus 6.
Du.
1 dx.
Cross that out.
That's kind of nice. Okay, so we've taken care of the u. We've taken care of the du, so we've got the x plus 6 and the dx taken care of. We cannot take care of this yet. What do we have to do?
X is u minus 6. Yep. Your x is just u minus 6.
Okay, so we have u minus 6 times u to the 1/2. Are we okay with that?
Yeah.
And then you distribute. So we've got u to the
3 halves. Minus 6 u to the half.
Miss Wright,
Mhm.
is forgetting the du a dead baby?
it would be the same dead baby as forgetting a dx, because you're just forgetting the width. Yeah. So it'd be a piglet, the width, wide piglet. I'm proud of it too. All right, so we got u to the 3 halves plus 1 divided by 5 halves minus 6 u to the 1/2 plus 1 divided by 3 halves plus c.
Two fifths u to the 5 halves. That's 40.
Don't forget about plus C.
You only need plus c in your final answer.
True.
If you're writing it all.
Well, so actually, if you're doing an FRQ, you need it all the way through because you're mathematically incorrect if you don't have it at any one point. Right? Thinking like a mathematician, right? A mathematician would be like, actually, you need to have it all the way through. You know?
What's the animal for forgetting plus c?
Hedgehog.
Starlight.
We're about to go.
So wrong.
All right, let's try 63
Not
because
even
it's
right.
beautiful. I love 63.
sunflower, but I feel bad saying it. So I say starlight.
Yes.
All right. Are we good with 61?
Yes.
We got it written down? Alex, how's your brain? You got it? We good? Okay. 63.
They're named after a former president and his brother.
I am very excited about this one.
That means we should not be excited about this.
I like this one.
Yeah, that means this is gonna be good.
I think it's going to be fun, Tiago.
Maybe it's gonna be really easy, so we'll be done quickly, and that's why she's excited. For it.
That's not why she's excited. So the U is
1 minus x.
1 minus x. The du is
Negative dx.
negative dx. I only have a positive dx.
So you divide by -1.
Okay, so here's my u. This is going to be a negative du.
X is 1 minus u.
It's actually an x squared in the front.
So don't you just
So minus the 1. U minus 1 equals negative x.
so it's
1 minus u is x.
1 minus u squared.
That hurts my brain so hard.
Oh,
I'm just going to leave it like this. Okay. And then we're replacing an x squared. So you have to square both sides. Well, what fun that is. Now, remember what we did the last couple times?
Multiply them together.
Yeah, we can't multiply them with the 2 right there.
Just FOIL it.
We gotta FOIL it.
Not that bad.
Okay, so I'm gonna go ahead and write what I have. So I've got negative u plus 1, negative u plus 1, u to the 1/2.
U squared minus 2u plus u squared minus 2u plus 1.
I didn't do that because it hurt my brain.
But it's okay if you write it.
It's okay if you write it like that, but it hurt my brain. I didn't like it.
Yeah, it's a little bit funky.
My brain was like, I know it's right, but no.
Working through the whole alphabet here.
Yep.
Was this just you wanted
Can we
to
use,
Yeah.
It's like having a positive number.
Okay, so we've got u to the,
3 halves.
nope,
Or, sorry, no. 5 halves.
minus 2u to the
3 halves.
plus,
U to the half.
Isn't it negative d?
what a beautiful, oh, we gotta do the negative. Whoa, whoa. Negative, negative,
Oh,
negative,
that negative?
negative. Whew,
Come on now.
man,
Don't be slacking.
that was terrible. That was terrible.
Isn't that a dead baby unicorn?
Yeah, but she remembered it. So.
Yeah, but it's not a conceptual error.
No. That's just.
Actually, that's a good one to put up there, though. I should make that be one.
Oh yeah, we would kill it. Wolf and I would kill it.
Yeah, I gotta figure out how to phrase it. Okay.
What's the most negative animal?
What are you doing?
Honey badger?
Donkey.
Why is your phone?
Eeyore.
Yeah. Eeyore.
So it'll be a donkey. A baby donkey.
Use a picture of Eeyore.
Toby.
That is terrible.
I know.
Shame on you.
Yeah.
Why are you guys laughing?
He made a very sad Eeyore joke.
Who did? What did Wolf say?
That's the sound of an emo screaming.
I'm not gonna say that.
What'd your dad say when you asked him?
I haven't asked him yet. I called him and he didn't answer. He texted me and said, "What's up? I saw you called me, but I couldn't respond since."
Oh, be careful to keep distributing that negative. I stopped halfway through.
Just call whoever's gonna pick up first.
Oh. My mom was driving to Asheville, so scrambling in the manager. She didn't like. What?
Nobody else can come up.
Yeah.
These guys are gonna wait to the
Yes, because you're coming, right? What?
Did you notice the rainbow
Why are
on
you
the wall?
so like in a bad mood?
We have a few extras too.
Is that okay, Lily? That's okay.